Hello, you're welcome back. All right, so we're still on polynomials. We're going to be solving questions, okay, in this video. So I have some questions here, and of course, this question actually deals with division of polynomials. Okay, so starting with the very first question, I'm having x raised to the power of 4 minus 8 divided by x raised to the power 2 minus 9. So we're going to apply that the log division method to actually do this. Okay, so the log division method, we're gonna write our log division. So this is the dividend, which of course is x raised to the power 4 minus 8. Then at this point we write our divisor, x squared minus 9. Okay, so I have to give I have to provide space. Okay, so here we go. So let's start. Of course, you know the sequence of our division, right? We first divide. After dividing, we multiply. Okay, after we multiply, we subtract. All right, so let's start with division. So s raised to the power 4 divided by s raised to the power 2, that gives me s raised to the power 2. Then I now multiply. S squared multiplied by s squared, I have s raised to the power 4. S squared multiplied by minus 9, I'm gonna have in minus 9x squared. Then the next is I will subtract. S raised to the power 4 minus s raised to the power 4, that is 0. That has been eliminated. So I'm left with minus 8 minus 8 doesn't have any like term, so that's going to be minus 8 minus 0. Okay, that's gonna give me minus 8. And of course, minus into minus 0 doesn't have any 9s squared doesn't have any like term at this point, so that's going to be 0 minus 9s squared. That's going to be plus. So what I'm having, okay, is as a remainder is 9 plus 9s squared. All right, minus is 9s squared. Then of course minus 8. Then I now go again. I'll divide 9s squared divided by s squared. All right, and that should give me plus 9. Then I now multiply. Okay, so multiplying 9 multiplied by s squared, I'm having 9s squared. Then 9 multiplied by minus 9. Okay, I have minus 81. Okay, so I subtract again. So here I'm having 0. That is gonna minus 8 minus that's plus. Minus 8 plus 81. Okay, that should give me 70 72 if I'm not mistaken. Okay, let me get a calculator. So that's gonna be 81 minus 8, right? Okay, 73. So my remainder is 73. Okay, so that simply means that if I divide s raised to the power 4 minus 8 by s raised to the power 2 minus 9, okay, I will end up having s squared plus 9 as my result. Then of course with a remainder of 73. Then don't forget you have to also divide by s squared minus 9. Okay, all right, so that is let's look at the second question, which of course is 2y minus 4y cubed minus 24y raised to the power 4 plus 2. Now I'm going to arrange this in ascending order. It will be much easier for me. So this will be part of the question. So I have the dividend. Okay, I'll arrange it in ascending order, right? That's going to be minus 24 y raised to the power 4. Okay, I mean in descending order. I'll arrange it in descending order of the power, okay, of y. Then I'm having minus 4 y raised to the power 3. Okay, then plus 2y, then plus 2. So the divisor here is 2y minus 1. Okay, so now let's start our division. Don't forget our sequence: divide, multiply, and subtract. So 24y raised to the power 4 minus 24y raised to the power 4 divided by 2y. Okay, that's going to be minus 12y raised to the power 3. So I multiply minus 12 raised to 12 raised to the power 2 multiplied by 2y. That's going to be minus 24 y raised to the power 4. Minus 12 y raised to the power 3 multiplied by minus 1. That's going to be plus 12y raised to the power of 3. So I subtracting minus 24y raised to the power 4 minus into minus 24y raised to the power 4. Of course, this minus here will actually be plus now, right? So this is 0. Then I'm left with this minus 4y raised to the power 3 minus into minus 12y raised to the power 3. Okay, so that's gonna give me minus 16y. Minus 16y raised to the power 3. Okay, so then of course bring down this 2y minus 0 is still 2y, right? 2 minus 0 is still gonna be 2. So I'll go please pardon me. I'll go through the process of dividing again. Okay, so that's gonna be 16y raised to the power 3. 16y raised to the power 3 divided by 2y. This time around I'm gonna have minus 8y. 8y raised to the power 2. Then now multiply minus 8y raised to the power 2 multiplied by 2y. That's gonna be minus 16y raised to the power 3. Then minus 8y raised to the power 2 multiplied by minus 1. That gives me minus, okay, plus, please pardon me, plus 8y squared. Okay, so let's subtract. This will be 0. Then here I'm having plus 2y. Let's start with this already. 0 minus into plus 8y squared. Okay, so that's going to minus 8y squared. And of course, plus 2y. Then plus 2. Okay, so let's divide again. So minus 8y squared divided by 2y. That's going to give us minus 4y. We multiply minus 4y multiplied by 2y. That's going to be minus 8y squared. Minus 4y multiplied by minus 1. That's going to give me plus 4y. We subtract. If we subtract, we end up having 0 here. And here having 2y minus 4y. All right. So that's going to give me minus 2y. Then I bring down the plus 2. I'll go again 2y divided by minus 2y, or minus 2y divided by 2y, right? That's gonna give me minus 1. I multiply minus 1 multiplied by 2y, that's minus 2y. And minus 1 multiplied by minus 1, that's gonna be plus 1. I subtract. This is gonna give me 0, and my remainder now is gonna be 2 plus 1, which is 3. So I hope that is well understood. Very simple. Okay, so we are going to continue with some other subtopic, right? And this time around, we're going to be looking at partial fractions. We're going to be looking at partial fraction. Okay. Now, as the name implies, partial fraction is simply the parts of a fraction. Okay. The parts that actually give rise to a particular fraction is a partial fraction. For example, let me illustrate using simple numeric fraction. Let's say you have 1 all over 2 plus 2 all over 3. If you are to simplify this, of course the LCM is 6. 6 divided by 2 is 3. 3 times 1 is 3. 6 divided by 3 is 2. 2 times 2 is 4. So when you add this together, you're going to have 7 all over 6. So you discover that simplifying these two fractions actually give you one single fraction. Okay, but if I should split this single fraction, I will not have these two fractions. Okay, so the process of splitting this fraction to give its parts is what we do in partial fraction. Okay, so anytime you are to actually express a fraction in partial fraction, you are actually you're splitting that fraction to get its component fraction. Okay, so I hope that is well understood. Now let's see examples. And basically in partial fraction, okay, we actually work with algebraic fraction. Example. Okay, so now let's look at fraction. Okay, express 1 all over x squared minus 4 in partial fraction. Okay, all right, so now how do we do this? Okay, so solution. Let's see how we work on it. But first of all, the denominator of this fraction, we need to actually express it out as a product of two factors. Remember, this is actually difference of 2 square. Okay, if you have if you know that already, s square, this s square minus 4 is something as 2 square, so this difference of 2 square. All right, and of course it's difference of 2 square, so you can express it as a product of x plus 2 and x minus 2. So that's what this denominator is. So I can write it in that form. Okay, so this is going to be equal to 1 all over x plus 2, then bracket close, x minus 2. All right, so now to express this into a partial fraction, I'm going to have two fractions in which one fraction will take this denominator and the other fraction is going to take this denominator, but what I don't know is their numerator. That is the whole idea. I want to find the numerator. So this interpartial fraction is equivalent to finding a fraction whose numerator is a, but I don't know what it is, but it will take this x plus 2 as a denominator, then plus the other fraction whose numerator is b. All right, I need to find it, but it take x minus 2 as a denominator. So okay, so now the whole idea of just to find this numerator, this unknown numerator a and b. So how do I do that? Okay, so I will have to evaluate this fraction, right? Of course, you know the LCM is x plus 2, and of course x minus 2. Okay, so let's start working. X plus 2 divide x plus 2, I have, and left with just x minus 2, then I multiply by a. That's going to be a into x minus 2. Then plus, I do the same. This cancels this, and left with this, I use it to multiply b. Don't forget my left hand side. Okay. So now, in mathematical expression, once you have the same factors at the denominator or at the same position in both sides of the equation, they'll cancel out. So I have these two factors, s plus 2, s minus 2, s plus 2, s minus 2, both sides of the equation. So they can simply cancel out. Why? Because if I should cross multiply, okay, they will definitely be at the denominator and numerator, all right, and they will still cancel out. So it's still the same, okay, the same thing or the same process I would have taken if I have rearranged the equation. So I can just cancel it out one time. So now I'm left with 1 is actually, let me be using equal to this time around now. Okay, this symbol here is a symbol means equivalent. All right, so now let's work on this. 1 is equal to a ax a bracket open s minus 2, then plus this was supposed to be s plus 2. Please pardon me. This cancels this. I'm left with this. Okay, so this s plus 2. So correct that mistake. So here I'm having of course b into x plus 2. Okay, so let's start. I want to find a and of course b. How do I actually find a or b using just one single equation? The way I would do that to achieve that very easy is to either eliminate a in one of eliminate a or even eliminate b. I can eliminate one, okay, and the way I can eliminate any of this variable a or b is to make one bracket to be equal to 0. So let's say I want to eliminate a so that I'll find b. I have to make the brackets that's attached to a to be equal to 0 by putting x to be a particular value that will make that bracket to be equal to 0. So when I put x to be equal to 2, then of course you know very well 2 minus 2 will be equal to 0, okay? So that's going to be any place I see x, I put 2. So I'm going to have a bracket open 2 minus 2. All right, then of course plus b bracket open 2 plus 2. So 2 minus 2 is 0, 0 times a, that is 0. So I'm left with 2 plus 2, that is 4. So I'm having 4a equal to 1. So here now a is going to be equal to 1 all over 4. Okay. Okay, so that is how I got my A. Now if I want to get my B, I have to please pardon me, this is B, 4B. So if I want to get my A, if I want to get my A, that means I'm going to eliminate the bracket that is attached. I have to eliminate B, right? So in this case now, for me to eliminate B, I have to put X to be equal to -2. All right, so let's go. It's going to be equal to A bracket open -2 -2, then plus B into -2 plus 2. All right, so let's do this. Of course, you know very well that this is going to be 1 equal to -4, -4A. And this is 0. Okay, so B is eliminated. That way, I can simply say that A is equal to 1 -1 all over 4. So I've gotten my A and B, so it is now easy now for me to express my fraction, okay? To express my fraction in partial fraction. So invariably now, I can now say that the fraction 1 all over, okay, x minus 2, that was my original fraction, right? S plus 2 and S minus 2. S plus 2 times X minus 2. If I should split it into partial fraction, I'll have A, which of course is -1 all over 4, then divided by X plus 2, then plus B, which is 1 all over 4, then divided by X minus 2. So this is just a simple method of actually expressing a fraction into partial fraction, okay? This is the simplest, okay? So this example is the simplest. So we're going to still look at more complex examples. All right, so see you in the next video. Thank you very much.